All right. Hi, good afternoon, everybody. Welcome to the University of Miami Rosenstiel School's open house for our Department of Ocean Sciences. My name is Heidi Van Buskirk. I'm a senior program manager here in our graduate studies office. I'm also an alum of our Master Professional Science program, which we'll be talking a little bit more about this afternoon. We're really happy to have you all join us. We have a great lineup of speakers for you today. You're going to get to hear from our wonderful faculty as well as some current students and other alumni. If you have any questions throughout the event, please feel free to drop them into the Q&A. We'll be replying to questions as we go, but we'll also have a bit of time at the end for a more open Q&A session afterwards. This webinar is also going to be recorded and available on our YouTube channel afterwards in case you miss anything or just want to go back and review any information. So a little bit about the Rosenstiel School. We are one of the leading academic atmospheric and oceanographic research institutions in the world. We're located on Virginia Key, just off the coast of downtown Miami, Florida, which makes us the perfect hub for the types of oceanographic research that we do. We offer three different types of degrees. We offer a Master of Science, a Master of Professional Science, and a PhD across all five of our research departments. We're just going to be focusing on our Ocean Sciences department for today, but if you have any curiosities about any of the other types of research that we do, please feel free to check out their websites or contact the program directors that are listed here. So why study at Rosenstiel School? There are many, many reasons. We've tried to narrow it down to just three. You're going to hear a little bit more about these reasons as we talk about some of the opportunities that we have available today. But I want to get to the assistantships and some important deadlines before I pass it off. So all of our PhD students are offered 5 years of support through PhD research assistantships. This includes a salary and 100% tuition waiver, as well as health insurance. There's a QR code here to all of our fall 2026 assistantships, but you're going to hear from our Department of Ocean Science assistantships in just a moment. Before I pass it over, just a few deadlines to keep in mind. Our priority deadline for our PhD and MS programs is December 1st. If you apply by December 1st, you'll have the highest chance of getting invited to our on-site recruitment weekend in February, and our regular deadline is January 8th. I'm going to pass things over to Professor Roland Romiser, who's going to talk a little bit more about our Ocean Sciences department. Roland, go right ahead.
Yes, hello, welcome to the Department of Ocean Sciences. I will share my PowerPoint presentation. Can you see this?
Yes.
Yes, good. So this is the overview of our department and our OCE, PhD and MS program. And so our department first, it focuses on the physics and chemistry of the ocean. Our department chair, Igor Kamenkovic, is here as well. He can confirm what I'm trying to say here. So we study the large-scale circulation, climate issues, sea interactions, remote sensing, and some other things here, biogeochemical cycles, marine organic geochemistry, marine microbial dynamics, trace elements, biophysical interactions, wide range of topics. We are about 25 faculty members, one of the biggest departments of the school. We have about 20 people, research staff, and about 20 to 25 graduate students. We have the graduate program in ocean sciences. That's the one we will talk about today mostly. We also are involved in the MPO program, Meteorology and Physical Oceanography. And we have two MPS tracks that we will also talk about later. And we also run a large undergraduate program in marine science. But that's not why you are here today. Here, a little bit about our facilities. Ship here, the Walton Smith. It can be used for a number of things. We also have large buoys that get deployed and some other instruments. Large computing facility. Here's something from a chemical laboratory. This is our wave tank Sustain, where they can make large waves and blow wind over them to study how the waves react to the wind and some other things. We have the satellite station here for downlinking and processing satellite images. Sea Stars, that's 45 minutes away from here. It belongs to the school. And we also have the helicopter and some other nice toys like drones and so on at our aircraft center for what does it mean? Environmental, no, for Earth studies, aircraft center for Earth studies. And now to our PhD program. It has 4 different tracks. Ocean dynamics, there's 1 student on it right now. Sea interaction, remote sensing, 9 students. Marine biogeochemistry with 7 students. And biophysical interactions currently with no student. You have to take 27 course credit hours. That means 9 courses typically for the PhD degree, 8 courses for the Master of Science degree. You do a comprehensive exam after the first year. It consists of an oral part and a written part. 2 written parts, actually, open book and closed book. And then you have a qualifying exam the 3rd year, which is similar, but focusing more on your own research topics. You will give 1 15-minute student seminar per year and the final 1-hour seminar when you are close to your PhD defense. And for the PhD, so how much research should you do? We expect typically materials for 2 peer-reviewed publications that should come out of it. Some people would say 3. And you will have opportunities to participate in field work and go to international conferences. Usually you will be fully funded, as Heidi already said, with some salary and so on, of a little more than $40,000 per year. And that's that. What else? Yeah, the seminars. So we have these seminars here, the COMPASS seminars, combined OCE and POATM seminar series. And I wanted to show you here our 2 web pages where you can look up what people have been talking about on the last few semesters on Wednesdays and Fridays. And there you see some student presentations, especially where you can see what our students are doing, because they all have to write an abstract for their presentations. And we also have this YouTube channel here. Look for it here, COMPASS on Demand, where you can see many videos of seminars that have been presented here by faculty members, also by Philip Tuchen, I think, when he applied for his position, and by Mary Bernardi-Biff, and almost everybody who is in this meeting here has a video there, except me. And that's it for now. That's my presentation of the program. Thank you for listening.
Awesome. Thank you very much, Roland. And now we're going to get into our assistantships that we're offering. I'm going to pass it over to Professor Mariana Bernardi-Biff.
Can you see my screen?
Yes, we can.
Okay, so I am Laurie Beef. Thank you for being here and for your interest in coming. The assistantship that I have to offer is called Illuminating the Nitrogen and Sulfur Cycles Using Biogeochemical Argo Floats. So the image that you see here is a BGC Argo Float, which is a platform where we can hook up some sensors, and I am very interested on chemical sensors. And they profile the ocean. They're thrown everywhere in every single ocean. And we have very high spatial temporal resolution of the different ocean properties, and then you can interpret what is happening at the different areas. It's a very multidisciplinary project. I am looking for a student that has strong chemistry and coding, and you're going to see why. And this student would then integrate shipboard, BGC Argo float data to interpret the different regions of the ocean. And it's a very data-driven fellowship, but my lab is very seagoing, so there are a lot of opportunities to join cruises as well. So just to illustrate, this is the type of data set that you would be working on. So this is a data set from the Eastern Tropical North Pacific that has a very interesting area that is an oxygen deficient zone where oxygens are so low that they drop to almost zero concentration. And in these areas, you have the nitrite, which is a very important nutrient, showing up. So here, in between these pink lines is where oxygen is very zero. So this is the type of data set that you would be working on and interpreting. This is novel data that resulted from a reanalysis of a sensor that was already existing in all of the BGC Argo flows. And this is more or less the spatial resolution of the data that you'd be working with and interpreting. So all of these black dots are tracks of BGC Argo floats that have been deployed and have been acquiring data. And in these red contours is where oxygen is super low. And in the pink contours where it's so low that it's almost undetected. So this is kind of the size of the data set that you'd be working with. So the first step would be helping me develop a database for the new data set for the nitrite concentrations over here, which is a new chemical. And then choosing the region of the ocean that you would be interested in working and interpreting these data sets. Another thing that can be done and very biochemical driven is because this chemical is very important when microbes transform nutrients into a nitrogen gas as the last step of the process. We can actually use this new component together with other measurements in a biochemical model and then model where the microbes are making water reactions throughout the water column. So these are just results from the model that we can incorporate this new measurement and then look at all of these different reactions that the microbes do and also under different regimes in the ocean. This component, nitrite, is also formed in areas where the oxygen is not zero as just a reactant between organic matter and the nitrate formation. So this is another idea for a student that is interested on phytoplankton and biomass formation and photosynthesis and interpret this data set that it was never seen before or something like this. So this is this color, the little spots here is where this nitrite is formed just below where biomass is high. And this is data from equatorial Pacific Ocean, but we can find this in a lot of other regions. Just to show you more or less what is the type of data that you would be working with. So basically during this PhD, the student would get trained in the use of large ocean data sets, especially chemistry, which is we're not very used to see very large data sets for chemistry. So this is a little bit new. Create global database of nitrite concentrations and interpret spatial and temporal trends. And this will be depending on what the student would be interested in looking at. Choose regions of interest to interpret and quantify nitrogen gains and losses. So as I said before, this chemical component is very important during microbial conversion from a nutrient to nitrogen gas. So like regions where we see this nitrate showing up are regions where we see loss of nutrients in the ocean. And additionally, as I already said, there are plenty of opportunities to join cruises across the world and probably even deploy some of these BGC Argo floats. Just examples of cruises that my lab is involved on. Next year, we are going in one in the South Atlantic Ocean, one in the tropical North Pacific Ocean. And in 2027, we have cruises in the Arctic Ocean and in the Sea of Cortez in the North Pacific to deploy floats and to validate data with cruise data. So yeah, it's basically this. And I will be here for questions at the end.
Great, thank you. And we're going to pass things over to Professor Igor Kaminkovich.
Can you see my screen?
Yes, we can.
Okay. Well, good afternoon. I'm Igor Kaminkovich. I'm a physical oceanographer, and I will describe the project that I hope one of you will join. So this project is on mesoscale ocean-atmosphere interactions over the Southern Ocean and over mesoscale eddies in the Southern Ocean. So let me briefly explain what this all this jargon means. Right, so here you're looking at so-called mesoscale variability over the world ocean. So you see all these features. By the way, these are satellite data, one of the types of remote sensing data that Roland Ramizer previously mentioned. So these are all these features that you see in different parts of the ocean are called mesoscale eddies. They are relatively large features, tens to hundreds of kilometers, but believe it or not, in terms of large-scale climate, these features are considered to be small. Typical climate models are not able to resolve these features. Again, they're too small for these models. And so the big question is how important these mesoscale features for the large-scale global climate. Our area of interest is the Southern Ocean. The Southern Ocean is loosely defined as a part of the ocean south of Africa. So you see that this part of the ocean that has very little land and lots of mesoscale features, this blue and reddish patches that you see on this diagram. Again, let me run this movie again. You see that these patches move around, they emerge, they disappear. Collectively, it all can be described as mesoscale variability. So in terms of interactions between the ocean and atmosphere, these mesoscale features are very important. They correspond to vigorous exchanges of heat, moisture, and momentum and energy between the ocean surface and the atmosphere. This is just a diagram. I won't have time to explain it. It's just an illustration of this kind of interactions and a summary of the processes involved. So both cyclonic and anticyclonic mesoscale eddies correspond to exchanges of heat and energy with the atmosphere. So, so our goal is to try to understand how these interactions and why they are important in large-scale climate. It's a complicated and important question. It's complicated because for a while we did not realize that these small features would affect large-scale climate, right? Why do you care about mesoscale variability when you're interested in large-scale global climate? Well, there are some indications that from numerical simulations that climate variability, large-scale climate variability, is very different in the presence of mesoscale eddies. There is a difference. So why is it so important? The problem, and I already mentioned it earlier, that climate models that are used for climate projections and predictions for predicting future climate evolution cannot routinely resolve these mesoscale features, these interactions. So basically, the models that we rely on are missing this important process. So our goal is to try to understand why these interactions are important and what processes need to be accounted for in climate models to be better, to be more accurate at predictions. So a little bit about the project itself. We are looking for a graduate student who can help us to figure it out. We need somebody with strong analytical skills. The student will be working with large data sets, enormous data sets, outputs from climate simulations. And this data will be 3 or 4 dimensional: latitude, longitude, time, sometimes depth. So large data sets, enormous amount of information, and the student will need to develop methods of extracting useful information from these petabytes of data, right? We have some ideas, but we are looking for a student to develop her or his own ideas, right? And use different tools to analyze this data. So math skills are important, analytical skills are important, understanding of physics of these interactions is important. But I want to emphasize that the most important skill, if I can call it that, that we are looking for is passion for science, passion for research. We offer excellent courses that give you necessary background. We will give you all the tools you need. What we need from you is, again, your passion for research, for science, your commitment to this long study. PhD study is a long process, of course, as you probably know, 5 years, right? So, yeah, so if you think you like this kind of science, please apply to our program, and hopefully one of you will join our team. Again, thank you for your attention. I'll be happy to answer your questions at the end.
Great. Thank you so much, Igor. And just a reminder for our attendees in the chat, if you have any questions, you can drop them in the Q&A. Our faculty will be available to type answers in the chat, but we'll also have a more open Q&A at the end of this session today. I'm going to pass things over to Professor Philip Tuchin. Excuse me. Philip, go ahead.
Okay, can you see my screen? Is it looking, how does it look?
Looks good.
Okay.
You are sharing your presenter view now.
Thank
okay.
you, Roland.
And click
Okay,
on
better
the,
like that.
yeah, now it's good. No,
Okay.
no, it's almost good. Continue to
Almost.
share.
Yeah. Okay, now
Yes.
good.
Perfect.
Okay. Yeah. Hi everyone. Thanks for joining and thanks for being here. My name is Philip Tuchen. I'm a seagoing physical oceanographer. I'm actually coming to Miami, to the University of Miami next year. So I'm very excited about that. And my research mostly focuses on ocean currents and waves in the tropical parts of our oceans and how they cause on how they impact climate variability, and also the other way around, how climate change and how climate variability impacts our tropical oceans. And in this project here, I'm specifically interested in how so Professor Kamekovic talked about mesoscale features. Here we are going in the submesoscale and even smaller scales in the tropical Atlantic. So in this figure here, you can see, if you've already seen it, it's the equatorial Atlantic. So we have South America on the western side and Africa on the eastern side. And it shows you the sea surface temperature in the colors. And you can see some large scale features, like it's warmer in the north and it's a little cooler in the south. But you can see all these kind of smaller scale features that we call fronts. So a region where sea surface temperature changes very drastically over a very short distance. And we have been interested in these features for a long time because there are a lot of interesting things, exciting things happening at these fronts, not just from a physical point of view, not just physical processes, but also biogeochemical processes as well. And in the last few years, there have been a lot of progress in model simulations that really reach into these kilometer scale processes or kilometer scales. But we don't really have an observational databases for most of these processes to say whether these models are doing a good job or not a good job. So with this project here, we want to address that gap. We want to observe and better understand small scale variability of processes at these fronts. And then we want to compare this to super high resolution model simulations and see what is good, what is not so good, where can we improve the models or model parameterizations. So that's the overarching goal. Right, so I just list a few of these processes that we're interested in. So there's mixing of upper ocean water masses that we are interested in. That's also very important for biogeochemical properties. There's also a lot of upwelling and downwelling of waters at these fronts. So all these things we are interested in. We are not. We can discuss with the student, but what's the interesting thing for the students. So there's some flexibility, but in general, that's the overall aim. So in the end, data model comparison, like I said, that's one of the main outcomes that we are aiming for. There's also, like I said, we are trying to gather these observations. So there's a huge field experiment scheduled for the summer of 2027 as of now. So there's also opportunities for seagoing work for the students, and it's going to be I think, a very exciting experiment. So we have a huge interdisciplinary group on that research vessel. Like I said, biologists, chemists, physical oceanographers, but also atmospheric scientists. So, and I feel like for the first time, at least in this region, all of them are working together on one process or one region together. So that should be very exciting. I'm looking forward to it. And what I probably search for most is a applicant with a physical oceanography background. I think that's the most easiest way to get into this project, I would say. But there's also also science or students with a background in meteorology or I would say ocean technology. We can also find some fields in this project for these students as well. So I think I keep it like this. If you have any questions, please feel free to send me an email. It's down here, or I can try and answer in the Q&A later. Okay, thank you.
Thank you very much. We're going to switch gears just a little bit. We're going to hear from one of our students in our Ocean Sciences Department, Sabrina Glenn. Sabrina, go ahead.
Hey everybody, I am going to share my screen. Alrighty. So, hi, I'm Sabrina. I'm a third year PhD student in the Ocean Sciences Department here at the Rosenstiel School. You heard our program director, Roland, mention that there are different tracks within ocean sciences. So I'm in the marine biogeochemistry track. We have some chemists, we have some physical people more on the physical end of things. And these different tracks allow us to all kind of hone our niche and carve a little bit of community and structure within our cohorts. So I just wanted to share a little bit of a student's perspective today. These are some photos from my PhD. So I'm in the Poppendorf lab, which is a chemical oceanography lab here at Rosenstiel. And you can see this Petri dish logo in the middle on the right-hand side. And so I made that while I was learning how to do culture work, which is something I did not know before my PhD program. And my advisor sent me to Woods Hole, and I was able to learn how to culture and enrich medias, enrich for certain bacterias, and a bunch of different skills on the biological end that I was not equipped with before my PhD program. So there's a picture of our lab logo. And then also all of these people in the top left-hand corner are my cohort from that summer program that I was sent away to learn how to do genomics and biological work. I'm a field-going chemical oceanographer, so that means that I spend a lot of my time both at the bench, on the computer, but then I also get to go all around the world on research vessels. So we've got a couple of photos here in the lower left. This is me with one of my undergrads who I've trained, and we went to Bermuda in January. So we did field work out there where we were looking at how much carbon goes into building biomass for microbes versus energy. And then again, this red photo up top is us when we were at sea. This one is from a trip we went on to California. So we were again looking at that carbon, the different places that carbon goes in the ocean. And that's me with some of my undergrads that I've trained. And I actually had an opportunity to be on the night shift there. So I was the lead grad student, the lead scientist for the night shift of the radioisotope fan, which was a cool leadership opportunity for me. And then this lower middle photo is actually me at my wedding with my advisors or my boss's daughter. So just wanted to display that Rosenstiel is a little bit of a smaller school. And that gives us a lot of really cool research opportunities in that the collaborations are very natural around here. But also like your relationship with your advisor can be whatever you want it to be. And my advisor and I are we're very good collaborators and a very good match, which I would recommend to you guys while you're going through this process. Make sure that you find someone who you really gel with because you spend so much time learning from them and collaborating. And yeah, Erasmus has some fabulous collaborations that you'll be welcomed into. So if you guys have any questions, feel free to reach me at my email, which I put on the slide. I'm so happy to answer any questions that you have.
Thank you so much for Sabrina. That was very enlightening. I'm going to share my screen now, and we're going to switch gears just a little bit again, and we're going to talk about our Master Professional Science program that I mentioned earlier. So I myself am an alum of this program. I graduated in 2020 with my degree in marine conservation. I really loved my time here at the Rosenstiel School. Again, we just have such amazing faculty. The students that I was studying with, really created a great community, and I feel like I got a lot out of the degree. As somebody who didn't necessarily come from a marine biology background, I came from more of a pre-med background. This program gave me all the skills that I needed to kind of shift and get a foot in the door into a science career in marine conservation. So, a little bit about the Master Professional Science for those who might not have heard of an MPS degree before. This is an innovative, flexible master's degree. It can be completed in about 12 to 18 months, so a little bit faster than a traditional Master of Science, which usually takes about 2 to 3 years. This is also, it culminates in an internship-based final project rather than a hypothesis-driven thesis, but this final project can be focused on research or professional skills, completely up to you. It's designed for students who are seeking advanced career-oriented training in marine, earth, and atmospheric science. So we do offer full or part-time enrollment. Full-time enrollment would involve about 2 to 3 semesters of coursework in addition to a 3 to 6 month internship. So there are 30 credits required to graduate the program. 24 of those would be your core course credits. And then there are 4 flex credits, which you can either use towards more classes or towards your internship. And then 2 of those credits need to be reserved just for your internship. So I do have a QR code here linking for more information on the MPS program. If you are curious, you can check this out. Again, this is going to be recorded and posted on our YouTube channel, so if you miss any of these QR codes, you can always go back. Both of our master's degrees here at the Rosenstiel School are self-funded, whether you're doing MS or MPS. But for our MPS students, we do offer some financial support. We offer a merit-based tuition, or 2 merit-based tuition waivers, actually, either a 3 credit or a 6 credit. This is based on either your GPA alone or your combined GPA and GRE scores. We don't require a GRE for admissions, but if you would like to take it, it can boost your chances of getting some of these credit waivers. So we look at your transcripts, and if you meet these criteria, we will either waive 3 or 6 credits, depending on which criteria you meet. We also offer the MPS Outstanding Applicant Award. This is a 24 credit award offered to students who apply before March 1st. So if you submit your application before March 1st, we'll reach out to you and invite you to apply for this award. Again, it's 24 credits, and to complete the Master of Professional Science, it's a 30 credit program. So this is a pretty significant source of financial aid. I have another QR code here for more financial aid as well as more information on cost of attendance. So in our MPS program, we offer 15 tracks, so there's a lot to choose from. We're just going to focus on our 2 ocean science tracks right now. We're going to focus on applied remote sensing as well as natural hazards and catastrophes. And before I pass things over, I just want to point out again 2 important deadlines that are coming up. We have our priority deadline, we'll have January 15th. So students who apply before the January 15th deadline and are accepted into the program are going to be invited to our new MPS preview weekend in March, which is very exciting. So during this weekend, you'll have a chance to come visit us on campus in Miami in person and learn a little bit more about the program. You'll also have the chance to speak to our faculty and current students in person as well. And then this is just a little bit of information on what we are evaluating the applications on. So we're looking at your GPA and your transcripts. We require 2 letters of recommendation, a statement of purpose. Again, the GRE scores are optional if you would like to submit them. And then for our international students, a TOEFL and a transcript evaluation are also required. I'm going to pass things off to our MPS senior program managers, Chelsea Begno and Kayla McEntee, who are going to talk a little bit more about some information sessions that we're offering this fall for interested students.
Thank you, Heidi. I am going to share my screen real quick, and we just have a few slides to talk a little bit about the MPS program and some of the ways that you can get more information about the program. So like Heidi mentioned, my name is Kayla McEntee. I graduated from the MPS program myself in May of 2021. And now I work in the MPS office as one of the senior program managers, along with Chelsea Begnow, my colleague, and who you'll hear from in a couple of slides. So something that I think is really interesting about the MPS program and that you'll see a little bit on this opening slide is just that all of the great experiences of the MPS program really come from this experiential internship portion of the program. And so most of these pictures, if not all of these pictures, are pictures submitted from students from their internship phase of the program and or from field courses that they took throughout their time in the program. If you are interested in learning more about the program, we have an MPS specific website, and we also have a prospective students tab on that MPS website that can talk about all the information you'd want to know when you're looking into a new program, like funding, like what student life is like, what your program could look like, what tracks you could be interested in, and so on and so forth. Some of the specific details I'd like to highlight for you are that we have a student resources tab or resources around University of Miami and Rosenstiel, alumni profiles, the MPS prerequisites, financing or education information, some frequently asked questions, and then also a Life at Rosenstiel page to get you introduced to the student perspective.
Thank you, Kayla. Hi, everyone. My name is Chelsea Begnow. I'm one of the senior program managers in the MPS office. I am also an MPS alum, earning my MPS degree in marine conservation in August 2021, and I've been working in the office for about 4 years now. We're happy to continue offering a very valuable resource to our prospective students and our newly admitted students to the program, which is our MPS drop-in hours. So Heidi, Kayla, and myself host these in the spring to answer any questions or concerns you may have about the program in general, track questions that you may have, application questions and recommendations. So we're really here to answer any questions that you may have about that process or what it's like being a student here at Rosenstiel. We will be offering these from 12 to 2 p.m. to allow people from multiple time zones to tune in at a reasonable hour. And you do not need an appointment for these drop-in hours. They are, as they are titled, you can just drop in for however long you need. We do keep our interactions one-on-one to respect the privacy of each individual that comes in. So we do welcome you to check out these dates on our website. We do have the QR code to access that hyperlink directly, and you can see we already have dates listed for January and February. So if you know you already have questions and you'd like to meet with us early in the semester in the spring, we'd be happy to talk with you. And that's the information that we have. If you would like to meet with any of us, whether it's Kayla, Heidi, or myself, we do have Calendly links for you to schedule an appointment with us. Kayla and I have our Calendlys directly linked right here, or you can reach out to us via email and we'd be happy to talk to you more about the program. Thank you.
Thank you, Kayla. Thank you, Chelsea. We definitely hope to see some of you in those drop-in hours or in our personal information sessions. And now I'm going to pass things over back to Roland, who's going to tell us a little bit more about our Applied Remote Sensing MPS track.
Yes, can I say something about the PhD program quickly before we begin with that? Someone asked here what these different tracks of OCE mean and how you decide into what track you will get. We have this web page here, right? I hope everybody has seen this here with the available PhD assistantships. This is for the whole school, including our positions here, Mary Bernardi Biff, and Igor's position and Philip's position. These are the positions. You should ideally be interested in one of these positions and make that clear in your application. And that connects you to a specific advisor. And with the advisor, you are usually connected to a specific track of our program. You should not just apply without really knowing well what you want to do. It's much better when you can indicate from the beginning with whom you would like to work in which position. Maybe you will end up with something else, but if you have no idea at all, maybe nobody will even look at your application because we will focus on the ones where people have indicated they were interested in our specific positions. Now I will show you this, which I made just yesterday, about the applied remote sensing track in the MPS program. So in this track, you learned about satellite remote sensing techniques mostly. There are some other remote sensing techniques, but mostly satellite stuff. What can we measure from satellites? What instruments do we have? Radars, radiometers, all those things. How to process and interpret the data. And why would you want to learn this? The typical job perspectives of these MPS people with an MPS degree can be to become a routine data analyst for some government agency, right? Like making on a routine basis wind fields for some weather services, surface temperature fields for NOAA, oil pollution maps for some environmental agency, something like that. You could also get involved in data analysis for some research team at a university or at some research center where you are the person responsible for downloading and processing and preparing the satellite data so they can be interpreted by the scientists there. The same at some commercial service providers that work with satellite data. You will probably not be a full scientist who will do your own research. That's not what the MPS degree is for, but you will work for people who need information derived from satellite data. We also had someone who went to a policy-making agency in Washington, D.C., where they do studies to give advice to the government. Our track is small, typically just 2 to 5 MPS students per year. Maybe we are trying to get a few more, but the advantage for you when you are on this track is that it's a very personal connection. I would not say what Sabrina said, that you can have all kinds of relationships with your advisor. I would be a little more careful with that. But we can certainly be friends. You can come to me all the time to ask questions and to discuss your career plans and so on. That's the advantage of our small track. Then some satellite data examples here. This is a very old synthetic aperture radar image from a European satellite of the Strait of Gibraltar. Here you see the mountains, you see internal waves. In the ocean, you see a black line there, that's an oil spill. So that's what you can see in a radar image, and we will discuss how you can and why you can see it and what you can do with it. This is a temperature field here on the right from an infrared radiometer satellite. This needs a few days that the satellite flies around the Earth to make a complete global map, but every few days you get a new map. We will also discuss how that works. What else do we have here? Yeah, so you have 2 core courses that are taught in the spring semester by myself. Introduction to Ocean Remote Sensing and Advanced Ocean Remote Sensing. Recommended additional courses are the Introduction to Marine GIS, Geographical Information System, and the Statistics course. That's a course that most people have taken. Aside from that, you have many other choices, and we have a broad range of interests. There are people who wanted to go more into using satellite data for studying some things on land, volcanoes, the Everglades, how things are changing in the Everglades, something like that. Or people who wanted to do something more with the ocean, or who were more interested in political things and they took some political sociology courses or something like that. You have a lot of flexibility here. Tailor your curriculum to your career plans. I think for this year, I had a particularly large number of students because I made clear to them you can do many different things on our MPS track. The main theme here is only applied remote sensing. We have, as I already said, our satellite receiving station here, SeaStars. This could also be a place for you to do your MPS internship, maybe even to get a job after you have the MPS degree. And what else? And that's the last slide. Thank you very much. Questions will be answered later.
Thanks, Roland. I'm going to pass things over to one of our Applied Remote Sensing MPS students, Leora Wilson.
Beautiful. Hello, everyone. My name is Leora Wilson. I am currently in the MPS track doing applied remote sensing with Roland Rollmeiser as my committee member and advisor. I will be graduating this semester, so I literally graduate tomorrow, which I'm very excited about. But during my time here, my background is actually in geophysics, and I have a minor in oceanography. So I was able to bring in all of my background and interests into my MPS program. It's been incredibly flexible. So I was able to take marine geoscience classes along with my applied remote sensing courses, which has been lovely. Instead of working at Sea Stars, which I would have loved to do, I actually chose a private consulting firm here in Miami to do my internship with over the summer. It was a lovely opportunity, and I got a little bit more experience in the industry that I'm interested in, while also working here in Sustain. So we have a laboratory here at the University of Miami. We simulate hurricanes for a variety of different applications for, from coastal resilience, for coastal engineering, all the way to we do some projects with the coral team and biological sciences. So there's a lot of opportunities here at UM if you're interested in, getting in and out to get working in industry, or if you would like to stay and, pursue other opportunities here at UM, such as working in different laboratories that we have available. It's all up to you, and you can tailor your path however you see fit. Everyone here is incredibly kind and welcoming, no matter what your background is.
Thank you so much, Leora. And finally, last but not least, we have Tamayas Gachman, who's going to tell us a little bit more about our final Ocean Sciences MPS track, Natural Hazards and Catastrophes.
Okay, good morning, everybody. Can you hear me and see everything?
Yes, we can.
Okay, I'm here to talk about Natural Hazards and Catastrophes degree track in MPS, which can also be understood as Environmental Risk Analysis and Management. Here you see some photos just to explain the problem. These are floods in Germany a few years ago. This is floods in Libya, destroyed the whole town. This is in Italy. In other words, we live in these natural hazards all over the place. And the risk is a keyword. The risk is best explained as unknowns and uncertainties about the future. And Ronald Rumsfeld, he was the defense secretary of US a few years ago, engaging in war. He explained it the best, in my opinion.
Reports that say that something hasn't happened are always interesting to me because, as we know, there are known knowns. There are things we know we know. We also know there are known unknowns. That is to say, we know there are some things we do not know. But there are also unknown unknowns. The ones we don't know, we don't know.
So this 35-second video really explains a lot. It's a very deep thing about known knowns, unknown unknowns, things like that. You may find it and think about it later on. So do we have risk due to natural hazard? Yes. Okay, we have risk and a lot of damage associated with that. So these are some numbers. We had, for instance, over the last few decades, hundreds of weather and climate disasters exceeding billions of dollars. Last year alone, we had $300 billion losses. They come in all forms: hurricanes, flooding, fires, all kinds of other things, earthquakes, volcanoes. We don't have volcanoes in mainland, but we have it in Hawaii. So it's all over the place in all continents. Now, one way to think about this is the idea of insuring. In other words, you distribute the damage. So the idea of insurance has been around for a long time. So it goes back to all the way to Mesopotamia, Hammurabi times, 4,000, 5,000 years ago. Okay, and it typically follows major catastrophes. Okay, you have a big event, you realize you cannot deal with it alone, so you go to insurance. And therefore, this track is very closely linked with the insurance industry. So we had, this Mesopotamia, Greeks, Italians, because they were doing that in the trade and the fires, things like that. So whenever you have a big event, you understand the issue of insurance, and this track is also about insurance. Now, why is it's been going on for 5,000 years? Why is it different? Why is it more important? Because we have a huge population explosion that happened mostly after the Second World War. Okay, we had peace mostly after the Second World War, and I can go and talk about it for half hour. But population over the last century increased by 5 times globally. Distribution is changing, mostly in the Northern Hemisphere. And then the wealth, okay, everybody has one house, two house, three house. Wealth is increasing. With wealth and population increase comes all these hazards impacting the society. And you can also see it here as time goes on, we have more and more and more expense because we have more to lose. So it's a very lucrative business in some way if you are on the other side of the deal. Okay, so this is really financially important track. Much of the track is learning about catastrophes and hazards, about atmosphere, geological hazards, hydrological hazard, this hazard, that hazard, statistics. But also we are connecting more recently. I just had a meeting in the business school with the dean of the finance department. We want to include some financial courses, one financial course that is really key to completely wrap this program up to be useful to you. Now, the most popular internships are in reinsurance companies. Those are insurance companies for the insurance companies, and cat modeling. It's global. There are many, many, many companies doing business all over the globe. And cat modeling is not like writing hurricane codes or something. Those are all in place. What you do is you essentially try to synthesize everything. You have a hazard module, which is and then you have vulnerability module and financial module. So you work with the whole thing together. And as far as I know from the students that go there, in recent years, we had at least one student going to these companies, and they're very, very happy, and they get jobs. I mean, we just had a student who got a job. It's not like you'd graduate into vacuum. You are hired by the company. Typically, you do internship with. I'll stop here for the interest of time. Thank you very much for your attention to this matter.
Awesome. Thank you so much. So that just about wraps up our programming for the open house this afternoon. I'm going to share my screen one more time just to direct you all to our website, which is earth.miami.edu. When you get to our homepage, you'll see on the right-hand side, there's this little drop-down bar that has 3 sections to request info. So if you want more information about the program, you can go there. We also have tours, campus tours, Monday through Friday at 2:30. If you'd like to come and visit us in person, you can sign up for a tour there. We also offer virtual tours of our campus that are on our website. And then the last little drop down here is number 3 to apply. So if you would like more application instructions and information on how to apply, you can head there. I'm going to share just a few last QR codes. Again, to the virtual information sessions, like Chelsea mentioned earlier. Chelsea, Kayla, and I are all available to speak with you in short 15, 30-minute information sessions, either over Zoom or over phone call. You can also, again, visit our campus in person if you'd like to come down for a tour. And then this is a QR code link to our Department of Ocean Sciences faculty. So if you have any questions, their emails and office phone numbers are all there. I would say email is probably the best way to get a hold of most people, as we're not always in the office. So please shoot them an email if you have any follow-up questions. But we want to thank you all for being here today. We do have a few more minutes left in our time, so I'm going to open up the Q&A if anybody has any questions, or if our faculty have any more information that they would like to share. I would say go right ahead. Let me see, I'm going to open up the Q&A here and see if we have any questions. I see we have one that was already answered. I do have another one here. Oh, here we go. Will there be a virtual open house for the Marine Conservation MPS track? So we'll be hosting a kind of general open house on January 6th. We'll be sending out more information about that pretty soon, so you can keep track of us on our social medias or go to our website for more information about that. We should start advertising for that soon, but we'll talk a little bit more about some of our other MPS tracks in there. Of course. Thank you for joining, Candace. And I have a question for any one of our faculty who wants to answer this. Just in general, what types of careers do you usually see your students going into after graduation?
I can answer that to some extent because we had to do some statistics a while ago for some kind of review of the school or so, and I think in OCE we had a really large number of former students who stayed in research and teaching and who had become professors and so on. I think more than half of our students end up being professors or high-level scientists at some research institutions. Also, there was basically nobody who was unemployed or something. They all got good positions. And the same is true for our MPS students.
Hey, thank you, Roland. And let's see. Another question I have.
Could I provide a student perspective on that?
Please, Sabrina, absolutely.
Awesome. So I came in fully intending to become a professor on the other side of my PhD program, and for a couple of years I was very committed to that. The more that I learned and was exposed to while in university, I decided that my skill set is probably better used elsewhere. And so part of the benefit of being affiliated with a larger university like the University of Miami is that you can kind of pivot and you have access to a lot of opportunities. For me, that began as taking some classes over in the business school and getting involved in startup companies and like how we can actually get our science out there through technology. So regardless of how you enter your PhD, there are so many opportunities to pivot your career while or whatever graduate program you're in. There's a lot of opportunities to pivot throughout.
Can I make another comment on this? You see Mary Bernardi Biff here. She was the first OCE student who finished the PhD in our program, and now she is a professor in OCE, right? We also have Milan Čurčić, who finished the PhD in MPO a few years ago and is now a professor in OCE. And we also have Mary Beth Akodia, who is not in our department, but in the atmospheric sciences department. She did the same thing there. She finished her PhD not long ago, and now she is a professor. So some of us they usually go away for a short time to work somewhere else, and then they come back very quickly to become a professor here. And some of us are getting old now, and we will retire eventually. I will not retire so soon, but some others. And there will be new positions here. So it's if you are good, there may be a chance that in 10 years from now you can be a professor here at our school, like Mari.
Yeah, I just want to comment that I am a professor here, but when I left my PhD, I became a researcher in a nonprofit research institute that does a lot of engineering for oceanography. So I actually left academia for 6 years. And then I decided that I wanted to come back to academia. And the only place on earth that I would leave my job to be was here. So I came back. So that tells you how good it is to study here and to live here.
That's great. Thank you all so much for offering your perspectives. I hope that was really helpful for some of our attendees in our chat. We are at time right now. So again, if you guys have any questions, please feel free to reach out to either myself or any of our faculty members that were here today. We're happy to answer any questions that you have. And we really hope to see you all on campus soon. Have a great rest of your afternoon, everyone. Bye.